With our do now today, I'd like you to approach it like a part of our lesson because there is a classwork example that's extremely similar to this, so let's take that same focus here. The following ordered pairs, -2, 4, 0, 8, and k plus 5, 10, are all points that lie on the same line. Find the value of k. So they all go on the same line. So that means we need to, I guess, find the equation of the line. And then almost treat that as if it were just a missing value. So when we're finding the equation of the line, right, step 1 is going to be to find the m, find our slope. So let's use our table method. We can do x, y. Let's put in -2, 4, 0, 8. I can see our change in y is +4. Our change in x is +2. So our slope, change in y over change in x, is going to be 4/2. So 2. Now we found our slope. Let's work on finding b. So we've got our equation, y equals mx plus b. I know I'm going to need an x, a y, an m, a b. We know the m is 2. X and y, I'll choose from up here. I'm going to choose this guy here. So x is 0, y is 8, and we're looking for the b. So we substitute in. 8 equals, that's going to be 2 times 0 plus b. 8 equals 0 plus b. So 8 equals b. Wonderful. Step 3, we're going to write that equation. Right, and we're going to write it in y equals mx plus b form, and we'll substitute in for m and b. Y equals 2x plus 8. So now we can take that equation to find that missing value in k plus 5, 10. That's an ordered pair. That's taking on the format of an x and a y. So we're going to take that whole k plus 5 and treat it as the x variable and substitute it in for x. So we're going to substitute in 10 for y. And then k plus 5, notice how I'm using parentheses, for x. Now we just solve for k. So we're going to distribute the 2. Combine our like terms. So we get 2k plus 18. We'll subtract 18 from both sides. -8 equals 2k. Divide both sides by 2. And -4 is equal to k. And that's our final answer. Find the value of k. There it is. Final answer. A lot of work, but it got us there. Some of you might be saying, there's got to be an easier way. And there is. The way we can do this a little bit easier is really by extending our table and using our knowledge of slope. So this is an alternate method. As soon as we see that that m is 2, that means 2/1. So our change in y is 2, our change in x is 1. Let's look and see what happens as we extend this table one step further. So that means my change in y is a +2, my change in x is a +1, which means our next step in the table should be 10 and 1. Well, this ordered pair up here has a y value of 10 and an x value of k plus 5. That means k plus 5 must be equal to 1. So k plus 5 equals 1. Solve for k. K equals -4, just like we got down here. It's all about how you see the problem. I hope you took good notes on this because, like I said, it is going to be something we have in our classwork. We're on page 30 looking at our second day of parallel and perpendicular lines. Here we're asked to determine the equation of a line that is parallel to y equals 2x minus 1 and goes through the point 3, 1. So we're going to wind up graphing both lines at the end. So as soon as I see parallel, I'm thinking same slope. And remember, like we did yesterday, we're going to separate into that given and that, that kind of old line, and then that new parallel line where we have that same slope. Okay? We're given the equation y equals 2x minus 1, and from that we're identifying that the slope is m. Here in our new parallel line, we're going to write the equation in a y equals mx plus b form, and we know we're going to need x, y, m, and b. And because we're having the same slope, we're just going to take that 2 for our new equation. Our x and y are coming here from our point, so x is 3, y is 1, and our b is the unknown. So let's substitute in and then solve for b. So 1 equals 6 plus b, subtract 6 from both sides. We get that negative 5 is equal to b, which is important. And then we're going to write that new equation in y equals mx plus b form, where we substitute in for m and b. So that gives us y equals 2x minus 5 as our new equation, and then that old equation, y equals 2x minus 1, and we'll graph both. I'll start with our old equation, y equals 2x minus 1. Y-intercept is negative 1, so I start there on negative 1. Our slope is 2, or 2 over 1, which tells me goes up 2 to the right 1. I'm going to do that until we run out of room. And then go back to our y-intercept and go the reverse direction, down 2 to the left 1. Then we'll take our straight edge, connect our points. Remember to put arrows on the end of your line, and we are going to label it. Y equals 2x minus 1. Make sure those little details are there. I'm looking for those. Arrows on the end, labeling. Now we'll go and graph our second equation. Negative 5, same slope. We're going up 2 to the right 1, 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 and then reversing, down 2 to the left 1, down 2 to the left 1, and we'll connect our points. There we go, arrows on both ends, and we label. Maybe I should have waited to label until the very end because I kind of ran over it. All right, so now down below we're going to work with essentially the same idea, except now we're going to work with a perpendicular line. So determine the equation of a line that is perpendicular. As soon as I see that, I'm thinking negative reciprocal slopes to y equals 2x minus 1 and goes through the point negative 2, 5. Ooh, different point here, exciting. So we've got our given, or our old line, and we're splitting that with our new perpendicular, where I know the slopes are negative reciprocals. Okay, so our old line, y equals 2x minus 1, our slope is 2. Our new line, y equals mx plus b, we're going to need our x, our y, our m, and our b. They're perpendicular, so we're going to have that negative reciprocal slope. So what's the negative reciprocal of 2? Well, that's going to be negative 1/2. And then our x is negative 2, our y is 5, and we're solving for b. So let's substitute in. Ooh, that's convenient, that x. Negative 1/2 times negative 2 gives us a positive 1. So let's solve for b. Subtract 1 from both sides. We get 4 is equal to b. So now let's write our new perpendicular equation, where we'll substitute in our new slope and our new y-intercept. Y equals negative 1/2 x plus 4. So we'll graph that as well as our old line, y equals 2x minus 1, to see that perpendicular relationship. Let's start with that one because we already know how to do it. -1 on the y-axis, up 2 to the right 1. There we go. Down to the left 1. Grab our straight edge. And we'll label y equals 2x minus 1. I've got the arrows on there. Now let's graph our perpendicular line. Y equals -1/2 x plus 4. So 4 on the y-axis. Slope of -1/2 tells me go down 1 to the right 2, 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 down 1 to the right 2. Opposite, up 1 to the left 2. Okay, we'll connect our dots here. And we'll label. And the great thing about this intersection is we can see exactly where it is, that it happens at that point 2, 3. And if you can label it, why not label it? And that's something we're going to work towards on Monday with our systems of equations, finding that point of intersection. So as we go to do your classwork, right, we're going to see number 1 and 2 very similar. Number 3, like our do now, there's that little clue on page 31. On page 32, a little review of some stuff we did earlier in the week. I'd like to finish off today with 2 additional examples, which I think are going to be helpful for our test next Friday, June 5th. We're going to do 2 problems that are not in your booklet, because I think it's a good step in the right direction as to what you might see on our test next Friday, as well as what you'll be working towards in 8th grade. The following equations, y equals r plus 2 times x plus 6 and y equals 8rx, are parallel. Find the value of r. So you want to figure out what r is. First thing I notice is, well, where's r? It's right here, and then it's right in there. And where those are located in our equations, it shows me that r is a part of the slope. It's a part of our coefficient of x. And they're telling us that these equations are parallel. I know parallel lines have the same slope. So I'm going to use that fact to solve for r. I'm going to ignore everything else about the equation, just kind of pull out the slopes, and they're the same, so they're equal, which means r plus 2 must be equal to 8r. And let's solve for r. Subtract r from both sides. So we get 2 is equal to 7r. Divide both sides by 7. And there we go. R is equal to 2/7. Boom. Done. Okay. Next problem, the following equations, y equals 2p times x plus 6 and y equals 12x are perpendicular. Find the value of p. Again, where do I see p? Right here with the slope. Okay. What do I know about perpendicular lines? I know 2 facts about the slope. One fact is that the slopes are negative reciprocals. And the other fact is that the product of the slopes equals -1. Okay? So I see 2p as the slope, and I see 12 as the slope. Now, you can use either fact. I do think using the fact that the product of the slopes is equal to -1 is easier here, but it's a commonly forgotten fact. But let's set that up. The product, so that means multiply, is equal to -1. So we can just solve. 2p times 12 is 24p. Divide both sides by 24. P is equal to -1/24. Boom. Done. Today's math jokes for mathy folks. The teacher says to the student, "Why are you doing multiplication on the floor?" The student replies, You told me not to use tables. Get it? Multiplication tables? Have a great day.